Hello and welcome back to module number 5. Today we are going to we'll continue our discussion about probability distribution, but we are going to be more specific, which means that we are going to look at sample or random variable. What does it mean with that regard? So what we are going to do? I hope that in the end of this module, your basic terminology will grow a little bit, because last time we talked about sample space, we talked about event, we talked about simple probability and joint probability. We also talked about conditional probability. In this module, we are going to talk about in the context of random variable and probability distribution, and what is expected value and what is the variance on that. So we will cover, in this case, we will cover two type of distribution, different type of distribution: discrete probability distribution and continuous probability distribution. And under each type of probability, we will look at different distribution and how it play out with that regard. So we are going to talk about binomial, and we are going to talk about possession distribution, and in continuous we're going to talk about uninformed, normal, and experimental with that regard. But I want to go back a little bit to make the connection what I did last time with regard to probability. When we talked about probability, we talked about three processes that we often encounter. First is generate events that is known. Example, rolling the dice. We can calculate all the options that dice provide us, and by knowing that, it is a process that is already known. So it's a classical probability definition, and this is something that you can actually come more prepared. The second is basically based on frequency, and it's using data in order for us to do that. Example, when we are going to say that next day is going to rain, we can look at the history of the rain and show that every day, every year, at the same day, it's going to rain. Example, in Christmas, we expect to have snow. So again, we can show that through history and show based on your location if it's going to snow or not. The third is basically based on a subjective method. Base example, analyst that has predictions that a chemical will increase by the next year. Again, it's not based on judgment, it's not based on events that is known, it's based on his own, her or him own prediction. In this class, in this module, we are going to talk about random variable. And so random variable is a subject that can change and can reflect on the result that we are trying to calculate. So the variance can take a set different possible value. In the book, I provided the example of rent. But the most famous example of random variable is flipping a coin. Why? Because it's all known. In rent is usually because the landlord is getting crazy or wants more money, and it's again can be prejudged or based on data that every year he increases the rent. So this is something that I want to cautious you and make sure that you understand. In R, we have techniques how to generate this random variable. I will show you the simple example, but I will also talk about the command that is also known as run if. The command, when we do the run if, we are allowing to generate a number that is where any value, including functional values that can be added to it. And I will show you an example. The following example that I'm using in R will be posted on your canvas, so you will be able to see it. So in order for me to set up a sample, I set up a X, I set up a value 1 to 10, and I ask the R to generate a number for me. Why I'm so obsessed with R and why are we teaching statistics with R? Again, the issue of ability to manipulate or to provide the data or the result to be more custom to our needs, this is where the power of R comes into play. Example, in the sample of X, I can ask the R that will show me the results that are smaller than 8 or bigger than 9. And by doing that, I can narrow it down to my own needs. I can also ask the R, in compared to any other platform, is that I want the sample to be customized to only 5 numbers instead of the 10 numbers that already been given. In the case of the run if, again, I can run it and I have 3 numbers, and if I will ask the X1 as a result of it, this is what it will give me. So all of that will be posted on the canvas, so you will be able to run it and be able to understand what is it. But I want to go back to the basic, the premises of the probability, and it's all about the data. And we talked about that in the beginning of the class, or the first module in the class, about the 2 types, the categorical type versus numerical type. Categorical type is, example, married or not married. You cannot be both in the same time. Or political party. Nowadays, when we need to select our candidates, which is really important, but we need to select one candidate. We cannot select 2 candidates at one time. Numerical data is usually divided into 2 types, discrete versus continuous. Discrete is the number of children. And again, you have 3, if you have 3 children, tomorrow you probably will have 3 children. Tomorrow will not change the number of children you have. In comparison, continuous, this number can change because of the weather, because of, I don't know, any other type of effect that can generate the continuous effect on the data itself. Okay, so discrete random variable. What do we know about that and what are we trying to achieve? So we obtain by counting 0, 1, 2, etc. So when we toast 5 times, the count number will be 0, 1, 2, 3, or 5. 3, 4, or 5. And when we will try to do that with a coin, we will probably have more concise idea or the ability to capture that in percentage. Example, toast 2 coins. So we have the values and we can assign values to it, and by doing that we will be able to understand the probability that face or true or false will come out of it. When we are talking about probability distribution, we are talking about the variables that may be along the probability of assuming those values. So in discrete probability distribution, we list all the possible, and we are listing it in this format where X value of the random variable and the px is the probability associated with the value. But we also have the idea that mutually exclusive and collectively exhausted may be part of our equation. Mutually exclusive, nothing in common. Collectively exhausted, nothing left out. And so those are the things that we are really concerned when we are trying to calculate discrete probability distribution. Again, with R, the discrete probability, we have three sets, X and Y, two sets. And by doing that, we can see where it laid out for us with that regard. So in this case, 0, the first one is the X and the Y. And I don't know why I did it twice, but again, the idea is where we saying that and how we applying to that. Try it, you will try to understand that. Again, going back to our example from last time, we talked about sample space. And again, it's like all the 6 faces of a die or all 52 cards on a deck. All this is out in the open and the space is determined where we are going to do. So a simple event, it is the outcome from a simple space with one characteristics, and in this case, red card from a deck of cards. When we are talking about joint event, we are talking about involving two outcomes where the ace, which is the red card, coming from the deck of cards. So those are the things. We can also do the idea of summarizing or visualizing those events. When we are trying to capture that in tables, we have the idea of what it will look like and what it is embedded. When we are talking about diagnostic or visualization, we can create this idea of this is how the red cards works, this is how the black cards works, and this is the outline of it. When we are looking at simple events, the event of a happy face, there are 5 faces in this collection out of 18 objects. So in this case, we can say that 3 of the faces with a light in colors, this is what we can count out of. So the event of happy face and light face will be equal to 3 divided by 15. We also have the idea of independent versus dependent events. 2 events that are independent if the occur of one does not change the probability of the other. Example, we roll 2 dice and flipping a head on a coin. If events are independent, then the probability of them both occur at the same time is the probability of the probability of each occurrence. So independent is that when 2 events are said to be independent of each other. Dependent is that one affects the other. So when 2 events said to be dependent, the probability of one occurrence influence the likelihood of the other. So this is important. Dependent or independent, again, the event of happy face, given it is a light color. So we can say happy face versus light wave. We have 3 items, 3 happy face given a light color, and that's the effect of it. When we are trying to compute probability, we are talking about the event, the probability of event. And in this case, it is marked by E. So the probability of E is the number of the outcome divided by the total number of possible outcome in a simple space. And we have the equation that X divided by T. Each of the outcome of the sample space usually, by definition, equally likely to occur. When we are talking about a joint event, we are talking about A and B. So the number of the event outcome from both A and B divided by the total number of possible outcome in that space. So if we will take it to a table, we will be able to see it more clearly about what is the joint probability, what is the marginal probability on that space. When we are trying to compound event A or B, and again the idea of or one or the other, again the same idea comes into play. And again, when we are talking about additional rule, when we are applying A1 plus B1 minus A1 and B1, this is where it is we apply it into our table, and for mutually exclusive events A or B, usually the formula is PA versus and PB. So the idea here, again, this is what we covered last time. When we are talking about drawing one card, and again with regard to red versus black, and again this is how I compute that. This is where the revised sample space take place in that equation and how we apply that. In conditional, again the idea of conditional, it's A and B divided by the probability of B. And when we do the idea of multiplication rule, we are multiplying A divided by B multiplied by B, or B divided by A multiplied by A. So the events of independent, this is the equation, and the event of independent, when the probability of one event A is not affected by another, which is event B. Now we are going back to our discrete random variable summary, which means that we expected value, which is the mean, the weighted average of the probability distribution. So it's the idea that we can expect or calculate the idea of the expected value. So the mean or the average demand of a long run is 1.1. So again, this is the example of it and how to apply that. The standard deviation of the discrete distribution, again, remember, I hope you remember standard deviation, and this is the formula for that in order for us to calculate that. An example, library loan program, we have distribution, we can calculate the probability, the x square and x square multiplied by px, in order for us to calculate, in order for us to understand where we are standing with that regard. So our analysis, when we compare the mean of discrete random variable, the square of each value of x, and recorded it the fourth column in the table. When we compute the value of x squared multiplied by x, we substitute the value of the mean with x squared using the formula, and in order for us to calculate that. So this is what we talked so far, but we need to add another dimension, and we need to talk about distribution. And there are two types of distribution when we are talking about discrete probability: binomial or possession probability. Each one of them, look at that differently. But we need to start with a basic. And in the basic is the idea of binomial distribution, where we have success and failure. One equals success equals 1, failure equals 0. So all of our calculation is based on that premises in order for us to do that. So the probability of mass function is x is equal 1 or p is equal 0, and we are trying to calculate the probability of success. In binomial distribution, we are adding another element, which is the idea that we can have mutually exclusive outcome of each trial. So in this case, we are trying to understand, it's not that the x1 or x0, we are trying to add another dimension to our calculation. So in this case, each probability is a trial. So the idea here is that we can apply with a replacement or without a replacement in order for us to justify our result. The idea here is that trials are independent. So the outcome of one trial does not affect the other trial. And this is really important. So when we toss two coins, we have two different distribution here. And the idea here is that we have a sample size, which in both cases is equal, but we have the ability to calculate for each success and apply that independently from each other. So in binomial distribution, we are calculating the mean and the standard deviation, and we're doing as the slide shows, and we are trying to do that in the idea behind it. In R, and this is really important, for every distribution that R handles, there are four functions. There are the root name, which is name of the normal distribution, and we have the idea of the P is the probability, and the Q is the quartile, and the D is the density of the function, and the R is the random variable. So in this case, binomial, those functions be called by binomial or Q binomial, and so on and so on. So the idea here is that we can use R in order for us to calculate binomial probability. If for the continuous probability, in this case, we are using a little bit more complex idea, but it again, the idea of how to apply that or how to integrate it into the R. For discrete distribution like the binomial, the D function calculates the density, which is caused by the F is equal to capital X equal X. So in probability in R, the binomial is a function that calculates the P and the F. And so in this case, we are giving it the number. 27 is the number of options. We have the size of 10, and we're looking at the probability of 0.5. In binomial, we can change the settings and we can calculate the two result or the two distribution in order for us to get what it outlined. So the result in this case is 0.08, which allowed us to calculate both of them. We are moving to the next probability, and Poisson distribution is the discrete events is the internal. So the probability of one success is the internal value. So the probability of more than one success is the value of 0. So the probability of success is the dependent form of internal to interval. So let us take an example. Customer arriving in 15 minutes. Defective per case for light bulbs. So we are using the following formula to calculate the distribution. This is again a little more complex. So we have here, this is a bad PowerPoint. So hold on, I'll change the setting so you will have, I'll change the setting in my presentation. Hold on, so just give me 2 seconds. Okay, so in this case he chose, but he did not play well with the PowerPoint, the PDF. So the idea here is that we have a distribution and we have the ability to calculate the mean and the standard deviation, and by following the following rule. So in this case, again, I will make sure that it will be concise, and you will be able to see what we have done. Whew. So I want to start going to the next stage, and which is the continuous probability distribution. You will have the slide, so you'll be able to go with the text and be able to explain each element. I know that is in a live class, it probably will be confusing, but I will have you all the text and everything else together, so it will make more sense. The continuous probability distribution, we are talking about uninformed, we are talking about other platforms of distribution. And when we have the probability of distribution, as we learned beforehand, is that we have the continuous probability distribution for a random variable x. So the most important is the idea of distribution, in that case, a normal graph. The probability of the normal distribution is that the mean, the median, and the mode are equal. So the normal curve is a bell shape and systematic about the mean. And so the idea here is that we have a total area of 1. The properties of normal distribution, again, I can calculate that, and when we have the mean and the standard deviation, and in the idea here is the center of the curve where we are trying to achieve, where's the points that are extreme. So the means and the standard deviation, an example of that will be the curve A is greater than or with a mean to curve B. So the line in this case will be equal 15 in compared to the line of the curve B, which will be equal 12. So again, the idea here is how do we calculate? What do we do with the standard deviation? How we make the comparison? And I am implying into here is the idea of the z-score. So the idea here is that the z-score is part of our equation in order for us to learn about the area, in this case, increase with that distribution. So again, the idea of the z-score is part of a z-table table that allowed us to find what it is and trying to achieve that by using it, applying it in that sense. So again, all of those things are part of normal distribution that we need to talk about, or we will experience that with that regard. Example of finding area under standard normal distribution. We are trying to figure out what is it stand for and how to apply that. We are trying to calculate that, but we are using the table to standardize or to calculate where is the z-score come into play. So I know I cover quite a lot and there is a lot to catch up, but I want you to start to be familiar with the terminology, with the simple space, events, simple probability, joint probability, conditional probability, and to talk about discrete versus continuous, and to address the idea of random variable in discrete and what is expected, and to talk about random sample and binomial and positional distribution, and talk about normal distribution. We did not cover all the aspects of normal distribution, I know, but I will cover that in the following class. But I want you to start having this terminology or ideas, because it will come back to us in the next module. I hope it helps. I hope it makes sense. I want you to continue reading the textbook, and if you have any question, please do not hesitate to ask. Until next time, have fun.